Hey you guys, Ms. Smith here. Today we're going to be talking about graphing exponential story problems with tables, number 2. And let me tell you what problems we're going to do. We're going to problem 1 and we're going to do problem number 3. So feel free to fast forward, rewind, pause, whatever makes this better for you. Let's read problem number 1. An architect is designing a tapered office tower where the ground floor, floor 0, is the largest and the floor space is reduced by 6% per floor. If the ground floor has an area of 1,170 meters squared, what is the area of the 8th floor? Okay, and we are going to be solving this using a table. That's why there's so much space below. So we don't want just the area of the 8th floor. We want the area of the ground floor, floor 1, 2, 3, 4, 5, 6, 7, and 8. So we can fill in our nice graph, and then we can say what the area of the 8th floor is. If you remember from the last one where we had tables number 1, we have these two formulas. We have our exponential growth formula and we have our exponential decay formula. So let's figure out, are the floors getting bigger or are they getting smaller as we go up the building? It says the floor space is reduced by 6% per floor. So if it's reduced, it looks like we're going to be doing decay because it's getting smaller. So first of all, make sure you're looking at your decay formula. That's the one with the minus sign in it. Now let's make sure we know our values for A and for R. The initial amount of floor space, it looks like the ground floor has 1,170 meters squared. So that's our A. Now let's figure out our value for R. R is always going to be some kind of rate. R stands for rate, and it's usually going to be a percent. In this case, it looks like our percent is going to be 6%. So R is going to be this number, but expressed as a decimal. So how do you write 6% as a decimal? If you were thinking 0.06, then you are right. And if you are confused about how to do that at all, here's my little trick. Take the percent, divide it by 100. That's what percent literally means, per 100. So 6 divided by 100, we'll put that into decimal form for you. Okay, now for T, here's the thing. If T stands for time. Time's not really passing here, right? But think about it as the thing that happens over and over. Like every time you go to the next floor, the floor space shrinks, right? So T is going to be actually what floor you're on this time. So you could just plug in 8 to the formula to get the answer, if that's all you needed, but we need to do the whole graph, so we're just going to plug in 0, 1, 2, 3, 4, 5, 6, 7, and 8 to our formula. I'm just going to say T equals X, or T, or I'll just say T equals T. How about that? So don't worry about T, that's what's going to change. We're going to leave it as T in the formula. If you'd rather write an X, you are welcome to do so. Okay, formula, Y equals, A is going to be 1170. Now we need parentheses 1 minus R. Oh yeah, R was 0.06. And then we'll just leave it as a T. You could even write F for floor if you wanted to. It's just really up to you. Okay, now our table, like I said, we need a bunch of values. 0, 1, 2, 3, 4, 5, 6, 7, and 8. That's probably off screen for you, but we'll just move the paper in a second. Okay. So that's the floor level, and then we're going to get the floor space over here in the Y column. So the X's are what floor you're on, and the Y's are the meters squared, the area of the floor. Now it already tells us the ground floor has an area of 1,170, so you're going to put that there up there with the 0. And now let's get our calculators and figure out what to put for the first floor. I'm going to use my formula. 1170, parentheses, 1 minus 0.06, and then my exponent is going to be whatever from this column. In this case, I'll do a 1. Exponent of 1 equals, and you get 1099.8. Great. Next one. Same formula. 1 minus 0.06, and this time your exponent is going to be 2. Now I'm also going to show you how to do this without the calculator. If you're at home and you don't have one of these awesome calculators, I'll show you how to do it on your smartphone or on your computer. Okay, So say all you have is a phone or a computer with you, you're going to go to the Desmos Scientific Calculator. You don't need the graphing calculator because you're making a table. All you need is the scientific calculator. Okay, so let's go there. And it's going to look like this. Again, don't put the y or the equals in there. Just put your 1170, and then you get your parentheses, 1 minus 0.06. Close the parentheses, and then to do your exponent, you're going to need this button that looks like the A to the B. A to the B is what you want. Hit that, and you're going to put an exponent of 3 in. And here's your answer, 971 point, let's round that up to an 8, 971.8. Okay, I'm just going to stick with this calculator and finish out the table. Let's make that exponent into a 4. 913.5, it looks like, 913.5. And let's make the exponent into a 5. 858.7. And bump it to a 6 for this line. You got 807.1. 807.1. And now exponent of 7. 758.7, and then we just got one more. And of course, if they had just asked the question, we could have just started with an exponent of 8. We wouldn't have needed all these values. The only reason we need these values is because we're building that graph, okay? So 713.2. And then we're just going to graph it. Okay, so 0, what are we counting by first of all? Looks like 1's down here, and then 100, 200, 300, 400, and so on. So 0, 1170 is going to be up here. And then 1, 1099 is basically 1100. So let's put that there. 2, 1033, something like that. 3, 971. 4, 913. 5, 858. 6, 807, 7, 758, and 8, 713. Right there. And that's all you got to do. Okay, connect your dots, and you are done with that one. Give me 1 second, I'll be right back. Okay, and I'm back. It's time to do problem number 3. So let me get my sticky note that has my little formulas on there. And let's read problem number 3. An employee receives a 4% raise once per year. If the employee's initial salary is $55,400, what will the employee's salary be after 5 years? So is this growth or is it decay? Is it getting bigger? Is it getting smaller? It says he receives a raise, so that's going to be growth because his salary is getting bigger. So we're going to use this guy. The equation with the plus sign is always the one for growth. Okay, now what is our value for A? What's the initial amount? That looks like 55,400. Okay, value for R, that's going to be a rate, so probably percent, 4%. We have to convert it to a decimal though, so it's going to be 0.04. And remember, you can always do 4 divided by 100 if you want to. And now this time, T for time actually stands for time. So if you wanted to skip straight to the answer, you would plug in 5 to your formula. But we want to build the whole table. So I'm just going to say T equals T. I'm going to leave it as a T because we're going to be changing that each time. Excuse me. So let's build our formula down here. Y equals, now we need the A, which is this big number, 55,400. And then 1 minus R, so 1 minus 0.04 to the power of T. Okay, and I'm going to go 0, 1, 2, 3, 4, 5, and we'll just end it after 5 because 5 is the number of years they give us. And there's my table, so these are my X's and these will be my Y's. 0, we don't have to plug into the formula because we know it's going to be 55,400. If you plugged that into the formula, you would get 55,400 out of it. Okay, now let's do 1. Use our calculator. And so we're going to do 55,400, 1 minus 0.04. And now we need an exponent of 1. And it's 53,184. 53. Uh-oh. Uh-oh. Miss Smith messed up. Who caught my mistake? Send me an email if you caught my mistake. I would love to hear from you. But look, his salary went down. So clearly I'm doing this wrong. And here's the problem right here. I used my decay formula and I needed my growth formula. So let's make that into a plus sign. At least it's easy to fix, right? 55,400, parentheses 1 plus 0.04, and then to the power of 1. That is so much better. If I was that employee, I'd be much happier about my salary going up than I would be about it going down. Okay, and now I'm going to show you on the phone. So using our Desmos scientific calculator, in case you are at home. Of course, when you're at school for your test and whatnot, you'll be using this guy, right? So make sure you're comfortable with that one also. But if you don't have this one at home, you can definitely use your phone. Here we go, 1 plus 0.04. Hopefully I'm doing this right, even though I'm talking at the same time. I think it looks good. A to the B, and my value for t is 2. And 59,920. Okay, let's go on. We're going to plug in a 3 this time. 3. 62,317. I should be doing dollars and cents. So 0.47, because this is money, so you really need dollars and cents. Let me go back to that value for 2. It was 0.64. And the value for 1, it didn't have an exponent, a decimal, so we'll just put 0.00. Okay, that's better. Now let's make this a 4 again. 64,810.16. And then make it a 5. 67,402.57. Okay, so after 5 years have passed, he's gone from 55,000 something up to 67,000 something. That's good. Let's get this on the graph. 0 and 55,000. So how are we counting? We've got 10,000, 20,000, 30,000. So each individual line looks like it must be 5,000. So 5,000, 10,000, 15,000, 20,000, and so on. So starting at 55,000, just barely above that, I'll put it right here. And then we go to 57,000 after 1 year. That's about halfway between 55 and 60. And now we're getting really close to 60,000, so I'll put it right here. And then for 3 years, 62,317. That's going to be about right there. And then 4 years, 64,810. It's getting really close to the 65 mark. And then for 5 years, 67,402. About like that. And there is your graph. You can't see much curve because the percent is really low. If you did this over years and years and years and years, you would see that it does start to curve a bit. It's just hard to see it over 5 years' time. That's all I got for you today. If you have any questions, ask your teachers. We love to help you, and I'll talk to you later.